So this question involves upper bounds and lower bounds. We understand that from the way the question is worded. It's saying by considering bounds, work out the value of m to a suitable degree of accuracy. It's given us numbers to so many decimal places, which again is implying that there's something to do with upper bounds and lower bounds going on here, because the number could have been bigger than 3.47, but it wasn't. It was rounded down to 3.47, or it could have been smaller than 3.47 and rounded up to 3.47 to correct two decimal places. So we're dealing with upper bounds and lower bounds. Therefore, we should be working out straight away what is the upper bound and lower bound for each of the values we've been given. So for S, then the lower bound is going to be 3.465, and the upper bound, again, it's a start question, so we should be really clear with our workings out. So the upper bound is going to be 3.475. Remember how the bounds work. The answer was given as 3.47 to two decimal places, so therefore we're using a scale that works in two decimal places, so 3.46, 3.47, 3.48, and the boundaries are the halfway marks, so the lower bound and the upper bound. And because it's about accuracy, we do allow the halfway numbers to be the boundaries. So 3.475 is the boundary. Anything up to, but not including that number, goes down to 3.47 and so forth. And for T, we can see that the upper bound, so the lower bound first, is 8.1315. and the upper bound is 8.1325. Notice that the lower bound and upper bound are always like one more decimal place on than the original number. So this was two decimal places, so our lower bound and upper bound are three decimal places, and so forth. With these boundaries then, we work out the upper bound and lower bound for m. So m, lower bound. So we use the values of S and T appropriately to make sure we get the smallest possible value for m. That's what the lower bound will be. So to allow that to be the smallest possible value, then I need to square root. Here we've just got to be careful, because let's just have a look what happens. If I do the square root of the lower bound of S, so the square root of 3.465, then I get an answer of 1.86, and if I square root 3.475, I get an answer of 1.864, so a slightly bigger number. So the square root of 3.475 and the square root of 3.465. So we need to make sure we're using the largest number on the top, so we're going to square root the upper bound of S, so 3.475. And because we want the lower bound, sorry, it's the wrong way around, isn't it? Yeah, the lower bound, we need the smallest number on the top. So we actually want to use 3.465. And we want the largest number on the bottom, because we want the smallest divided by the largest, and that will give us the smallest possible value for m. So we're going to do the largest value of t on the bottom. So that's going to be 8.1325. So that will give me the lowest possible value for m. So we're going to have the square root of 3.465, and then we're going to divide that by 8.1325. So that gives me an answer of 0.228890383. And then we need the upper bound for m. So to get the upper bound then, we need the largest possible value for the square root of s on the top, so that's going to be the square root of 3.475, and we need the smallest possible value on the bottom, so that's going to be 8.1315, so the numerator and denominator positions and so forth. So we do that with a calculator. So we've got the square root of 3.475, divide that by 8.1315, and then that gives us the largest possible value for m using these bounds, so 0.229248624. Then we remember what the question is. It's a styled question, which means we're trying to explain exactly what's going on. So that's what we've been doing here by showing what the upper bounds, lower bound are for S's and T's. Then we calculated the lower bound and the upper bound for M, because the question said we want to consider bounds. So we've worked out both boundaries, and we want to work out the value of M to a suitable degree of accuracy. Well, the suitable degree of accuracy means that we should be rounding both of these lower bounds and upper bounds to so many significant figures, and when the significant figure is the same, then we will say that's going to be the best value to use for M. So the lower bound to 3 significant figures is 0.229, and the upper bound to 3 significant figures is 0.229. If I did 4 significant figures, then it would be 0.2289, and for the upper bound it would be 0.2292. These are different, these are the same. So when we did 3 significant figures, we ended up with the lower bound and the upper bound having the same answer, and when we did 4 significant figures, they were different. So when we get the same value for so many significant figures, then this is the one we choose. So these were the same, so a sensible degree of accuracy for M is 0.229. So that's what the question means. So it's about finding the upper bounds and lower bounds, because it said by considering bounds. So that kind of shouted out find lower bounds and upper bounds. Find the lower bound and upper bound of S and T, put them into the formulas to find the lower bound for M, the upper bound for M, being careful to make sure you had the, for the lower bound, the smallest number on top, the biggest number on the bottom, and then for the upper bound, the biggest number on the top, the smallest number, so the opposite way around. Write out the full answers and then round appropriately to make your final decision of what is sensible for the degree of accuracy, 3 significant figures in this case.